Hello and welcome to my YouTube channel. I'm Michael and I recently decided to buy a CNC mill. This video is about my experience with the purchase of a CNC mill, how I got it into my garage, how I set it up, and the changes I made to the machine to fit my workspace and to fit my needs. First topic, why a CNC mill? I own a small mill already and it was sufficient to pretty much build everything I wanted. Takes a little bit more time perhaps, it's a little bit more tedious, but a while ago I bought a snapmaker machine, which is a combination of a 3D printer, a laser cutter and a small CNC mill. And working with the small CNC mill got me interested in CAM and CNC milling. The snapmaker also, the CNC portion of the snapmaker also runs on the same G code the larger machines do. So it was very helpful getting a head start on CAM in general. And also, by now probably the small machine paid for itself, because if you do a mistake, especially as a rookie, it's much cheaper on the small machine than it would be on a larger one. As a side notice, this is a pure DIY hobby workshop. I don't run a business here and I'm not sponsored by anybody. So all this is from my perspective as a hobbyist. Boundary conditions. My workshop is a dual purpose workshop / garage. I still park all my vehicles in here and have a decent number of machines installed already. I didn't want to give up any of those machines. I did not want to engage in street parking. So it was an add-on to an existing work environment. And I had to find a specific location for this machine. So the hard filter criteria when I started browsing the internet was space. The soft criteria were cost, brand reputation, user feedback on the internet regarding the quality of the machine, regarding the customer care of the manufacturer, and so forth. Under consideration of all factors, I pretty soon started focusing on Tormach. They had or have two machines which with the potential to fit in my workshop. User feedback in general is very positive regarding the quality of the machines as well as the customer care. They're located in the United States, their pricing seems fair, so that was my focus. Again, this whole evaluation is based on the fact that I'm a hobbyist. I'm not running a business. If you run a business, your outcome might be quite different. The two machines I had in mind was either a CNC 440, which is a smaller model, and the 770M, which is a little bit a larger model. Let's move to my computer and have a look at a 3D Fusion model of my workshop and explain the space requirements and the space limitations I have. Okay, here's a Fusion 3D model of my garage workshop. In general, a CNC mill needs to be accessible from all sides. Most open space in my garage workshop is used for parking my vehicles, 2 cars, motorcycles, scooters, and I found this area as the only viable option to place a CNC mill. Here is a Tormach 440 with enclosure and stand, here without. And here is the 770, again with enclosure, chip tray and stand. And it became clear that I could fit either a 440 with stand, chip tray and enclosure or a naked 770. In other terms, small with enclosure, which allows for flood cooling, or bigger with a home stand, homemade partial enclosure and no flat cooling. I decided that bigger is better and went for a 770. The exact placement of the machine was set to allow for clearance to the walls at maximum X and Y travel, and to avoid blocking access to the garage through this door. I placed the model of my homemade stand underneath the machine and projected the position of the 4 swiveling mounts onto the floor surface. Here. This allowed me to take measurements of those contact points, and I marked them on the actual garage floor. Regarding the height of the machine, the ceiling height at this location is 96 inches, and but there's a 4-inch cast iron water pipe hanging off the ceiling, which lowers the clearance height to about 84 inches. The highest point of the machine is about 88 inches at the cable channel to the headstock up here. Fortunately, the cable channel can be easily temporarily removed, and it should be possible to move the machine under the water pipe to its final location. When in place, the top of the cable channel is, let me get rid of the walls here. The top of the cable channel is behind the pipe here, and it should be okay with clearance in Z direction. Since we're here already, I might as well show you the machine stand I designed and built for the CNC mill before the machine was delivered. Let me take away the machine. Here we go. It's based on a McMaster steel table made of 7-gauge steel and a load capacity of 10,000 pounds, 30 inches wide, 28 deep, 24 high, and weighs about 110 pounds without drawers, sidewalls, and so on. I installed 4 soft closing drawers, drilled the top for the mounting holes of the machine base, and threaded additional holes for other attachments. I then installed, installed 4 heavy-duty 5-inch casters. The 2 in the front are swiveling, the ones in the back are fixed, and 4 5 of an 1/8-inch swivel leveling mounts with a load capacity of 5,000 pounds each. The casters are for moving the standing machine around only. When in place, here we go, the leveling mounts are lowered, lifting the stand of the casters to give the table a more stable setting. Okay, let's go back to the shop and have a look at reality. Okay, so here it is. First of all, there's a good manual from Tormach about moving and setting up the machine, and I don't want to repeat everything they explained already, and much better than I could do anyway. Instead, I'm going to focus on the different or additional steps I took. Let me start with how I actually got it to this location from here. The most common process, and the process typically recommended by the manufacturers like Tormach, Precision Matthews, is that you put the stand at its final location, then you pick up the machine with an engine hoist, move the machine with the engine hoist to the stand, and drop the machine on top of the stand. That process wouldn't work for me very well because, first of all, I don't own an engine hoist. I didn't want to buy one because they're kind of bulky and take up a lot of storage. And I was also not entirely sure if I could move the engine hoist with the machine dangling underneath the water pipe I mentioned earlier. So my process was a little bit different. First of all, I built this little lifting rig or lifting bar, which allows me to balance anything I lift by just adjusting these hooks to the left or the right. So then I lifted the machine, then I moved my stand, which has casters, as I mentioned, underneath the engine hoist, dropped the machine on the stand, bolted it down, and then moved the complete assembly from here to its final location. What helped a lot is that the delivery truck driver was kind enough to move my machine right underneath the hoist, and that helped a lot already, because getting this machine down the rather steep on-ramp to my garage would have been probably a challenge. So that worked quite well for me. I was actually surprised how easy it was to move the complete assembly. I could push this thing around with 2 fingers, so that was rather easy. So with the machine at its final location, I lifted the machine or the stand off its casters. They're freewheeling now. And then I started leveling the machine. The way I did it is, first of all, I centered the machine table in middle of X and middle of Y. I put one of these machinist levels in the middle of the table. They have actually amazing accuracy. The resolution of this level is 2/10,000ths of an inch over the length, that's 10 inch. So I put that in the middle of the table and then just adjusted the level with turning the 4 swivel mounts until it read 0. Then I moved the table to maximum and minimum Y to see if there's any difference between the 0 reading I had in the middle. In my case, it stayed 0, and probably speaks for the build quality of these machines. If there would be a little bit of difference, you would compensate that by shimming between the machine bed and the table. There's actually, I think, a formula how to calculate that on Tormach's website. So with that done, the machine was level, and you might ask if that kind of precision is not a little bit excessive, because the coordinate system of the machine really does not depend on the leveling of the machine. It should read 90 degrees between all axes, regardless if the machine is a little bit off balance or not. The only reason to do the leveling is actually to have a 0 baseline to indicate if there's a twist in the bed, and then to calculate the thickness of the shims. That's pretty much the only reason why you do it. My point is, if you do it, you might as well do it right. And also, there's a lot of tolerances adding up until you get to the contact between the cutter and the workpiece. And you might want to eliminate or minimize as many of those as you can. If you're lucky, they might cancel each other out, but Murphy's Law applied to machining tells us that they won't. If I would build another stand, there's one small detail I would probably change. I used 5.1/8" coarse thread swivel mounts. Next time I would use a fine thread with 18 TPI. The coarse thread has 11 TPI. The reason for that is the following. In order to achieve 1/1000th of an inch height difference with an 11 TPI requires roughly 4 degrees of rotation at the swivel mount. With 18 TPI it gives you 6.5 degrees, which makes it probably a little bit less sensitive or tedious to adjust the level. But that's pretty much the only thing. Otherwise, I'm quite happy how everything went. And after that, I attached pressurized air and electricity, everything according to Tormach's manual. And it's now time to go over the additions and alterations I did to the standard machine to make it fit my needs. As mentioned before, I installed 4 drawers in the stand, which gives me plenty of room for tools, measuring equipment, collets and so forth. Moving up, I built a, let's call it a micro enclosure. It's a stainless steel angle with some clear acrylic on top to prevent the chips from falling off the machine. To the right and the left of the machine are 2 chip bins. The inside of the chip bins is leveled with the top of the stand, so you can, with a little brush, you can just put the chips into the bins. Both bins have a door down here. You put a waste basket underneath the bin, open the door, and the chips just fall into the waste basket. The design of the right and the left bin is a little bit different. This is higher. Here I had to account for the movement of the table to avoid any collision. On top of it is another part of the small enclosure I built. It's also made from clear acrylic to give me the opportunity to see what I'm doing here. I can adjust the height of this. For smaller parts, I don't need it that high. Then makes it a little bit easier to access the part. But I can, it's a little bit awkward to do that from here. I can adjust the height and just fix it in place here. And the same is true here for the sides. Height adjustable. Let me move the camera back here. Again, in order to prevent chips from falling off the mill, there's another acrylic sheet to prevent chips falling off in this direction. Down here, I sealed off this opening between the table and the machine. The same is true on this side. There's tiny acrylic protector for the MQL, and back here another panel to prevent the chips from falling off the back of the machine. The front of my enclosure is held in place with these 2 wheels, and I can easily remove that. For example, when I need more space for larger work pieces. Just tighten these wheels and it's back on. On top of the table, to the left and the right of the vise, are 2 stainless steel plates. I built those to prevent chips from falling into the T-slots. So these can be easily removed and have a little notch here which holds them in place. Just pop in here. To the right of the headstock is a holder for a passive probe. I 3D printed this holder from black PLA, and I can use the probe, put it back in here without the need to connect and disconnect the cable every time. Next to it, reset and emergency stop button mounted up here, and a work light. To the left of the headstock, I installed the push button for the power drawbar, attached a little metal plate to it. That gives me the option to place the magnetic holder for my MQL here. Speaking of MQL, that's my own design. I actually designed that years ago for my other mill and then just copied the design, made pretty much the same for this machine. Comes with adjustable here with one wheel. It's very similar to a Fogbuster system, but I wanted to have a few additional features, and so I designed myself. It has two circuits. One circuit feeds air and lubrication to this nozzle. I have a second nozzle here with a magnetic holder, which is air only. The reason for that is sometimes when I work with wood pieces, I will still want to get rid of the chips, but I don't want to add any lubrication or liquid to the wood chips. Back here, pressure regulator for the air. There is a little switchboard where I can choose which nozzle to feed. I can also feed both nozzles at the same time. For example, when cutting deep slots, you probably want to have more airflow. There's a solenoid which allows me to activate or deactivate the system through a G-code or from Tormach's Path Pilot controller. Surrounding the MQL or micro quantity lubrication system is a TTS tool holder rack I built. It has 30 numbered positions for tools I often use, an additional 4 positions for general tool holders like chucks, tension compression holders. And further down here, let me move the camera real quick. I built this holder for an additional 6 tools specific to a project. I don't have enough tool holders to account for all my drills and thread mills and so on. So what I do is, if I need a specific drill, for example, for a project, I put it in the jug, take the tool offset, and then place the tool in here. Let's say it's drill number 213. I have a little number system here. So I have a set of numbers and 3D printed these holders. Put the numbers together here, slip it in here. It's hard to do with the left hand. Put it in here, and that indicates in this case, the drill number 213. And if I have a different project, I just change the number with drill 685. Also, I just built this little camera holder. If I take a video here at the mill, just pops in here. And is fixed in place with a little wheel. Close by, on the top of my lathe stand, is the surface plate to measure tool offsets. They're typically made out of ceramics or stone. I built my own for one reason, out of steel. My height gauge has a magnetic base, so that makes it less likely that I knock it over and it falls to the ground. And also, it prevents the height gauge from tilting when I measure a tool. So it works quite well for me. By the way, this is a tightening, loosening ER20 collet holder for TTS system, which allows to tighten ER20 collets with more or less one hand. That was the first project made out of metal I did on my CNC mill. I did not, at least not yet, order an ATC, an automatic tool changer system. The reasons being that I think I had to rearrange all my tool system MQL and so on to make space or move the machine forward a little bit. Also, the big advantage of an ATC is that you don't have to babysit the machine. Now, since I very, very rarely, the only time I can think of actually was the MQL system, which I built 3 times for the lathe, the mill, and the CNC mill. In general, I only built one part of a design. So even if you get into serial production, you probably want to watch the first part ever made of a design. It would take a brave man to run a project unobserved for the first time. So the main reason for an ATC that you don't have to babysit is not relevant to me. On the other hand, an ATC is just very cool, so we'll see. I will make a separate video about the tool management I established here, including the integration into PathPilot, Fusion tool library in the beginning. It took several iterations to find, as far as I'm concerned, a good system, and I want to share that with you. Also built a little tool which keeps the already entered tool offsets in PathPilot, keeps them when I change the tool library in Fusion. Wrapping up, I bought this machine about 4 or 5 months ago. So far I'm very happy. The build quality is great. The purchase process, including delivery, worked very well. Customer support, I had 2 issues, 2 problems, minor problems. First one, I could not log on to PathPilot Hub. I sent them an email. Within hours I got a response that it's going to work. Logged on, problem solved. And the second was that by mistake I ordered a jobber drill set, which I really didn't need. And I called customer support and they accepted the return with a very modest restocking fee. So there was also a very positive experience. That's the end of this video. Thank you very much for your attention, and I'm looking forward to see you very soon. Thank you.